Hello, everyone. So just a quick introduction about myself. So Jihad Tohme, I'm based in Rome, Italy. I'm a manager within the network capability in Accenture technology. Uh, I've been following, let's say, software-defined projects and implementations a little bit all around the globe. So anyway, feel free to reach me at the stand of Accenture. We can have a chat about the details for the sake of time. So getting back, let's say, to the content of this session. Let's say software defined. So what's all the buzz about? So let's make some clarification about the differences between SDX, SDDC, SDI, and so on. So it's all about the degree of penetration of this software defined concept with your data center. So mainly with SDX, so software defined everything. It's the umbrella of all the technologies that you will use to define, let's say, the software defined infrastructure. And after that, you will dig to your data center. And after that, you will have silos verticals on network, so SDN, SD-WAN, which will be the, let's say, the focus of our topic today. And of course, you will have also software-defined storage and software-defined compute. So let's see a little bit in details what will that mean. So as you can see here, so software-defined infrastructure will be actually all the technology aiming at minimizing the operator intervention. So if I do, let's say, all the intervention to get an SDI data center oriented, I will have a fully virtualized environment. I will have a high level of automation and orchestration, which means actually that I'm able to minimize at minimum the changes and the risk deriving from this, because mainly when I apply a change, when I do a change, it's all about the human error when I have, let's say, a risk. Agile development and deployment. So what would that mean? Actually, today, if I have to change something and to do something on my infrastructure, it will take me, let's say, weeks to plan, design, and so on, and months to apply it. So before getting all the approval and so on. With, let's say, this level of automation, I will be able to reduce this to be hours instead of months. We will anyway deep dive on this a little bit later. Auto provisioning. So what will that mean? With the auto provisioning, actually, let's say I will automate the failover on my virtual machines. So if I have a failure on my data center, I will have, let's say, a new VM deployed in a different data center or a different server in case of failure automatically, and this will also reduce time of rehealing, let's say, and of course the risk of the outage. Based on cloud technologies. So mainly, I will have an infrastructure that is private, public, or hybrid cloud oriented, which means actually that I'm looking to the future. So all the enterprise, or let's say almost all the enterprise, are starting to penetrate a little bit the cloud, so partially or totally, with a solution that is, let's say, software defined. I will be looking at how to say decouple, let's say, my logical solution from my physical solution. So I will not have my physical location for the data center, but I will have them spread between different locations that can be physical or virtual, let's say, so in the cloud. Fault-tolerant architecture, as I was saying before. And switching to the SDDC, as I was saying, so SDI was the concept. With the software-defined data center, I will be targeting with this concept all the elements that I will have in my data center. So networking, compute, storage, CPU, security, and so on. Our focus today will be around SDN. So the network, let's say, where I will be targeting with the same concept, so with the software-defined concept, to decouple the physical layer from the logical layer. Let's see a little bit more about this. So again, about software-defined data center, as I was saying before, so virtualization principles actually will be giving me abstraction, pooling, and automation. So abstraction, it's a little bit easy. So we will have actually a logical layers, actually two layers that are completely separated from the physical layer that we can see below. Pooling, what is pooling about? Let's see it like this. I will have one pool of different data center that can be physical location or the cloud, as I was saying, and I could manage them in the same way. So as if it was only one data center, minimizing outage, of course, and having, let's say, native high availability and so on. So I will be also able to pool also my capacity of in terms of resources. So I will be able to use the totality of my CPU, RAM, disks, and so on. The control point, of course, is moved from the physical part to the logical part. So I will have usually a portal that allows me to do all the control part. It's completely hardware agnostic usually. The management is defined is policy based. What actually this mean? This means that I will be able to define policies, and I will see, let's say, how to say, my elements will not be anyway the physical appliance I have in a data center, so switches or servers, but I will have mainly application, or let's say what will be called after that. It's similar to the concept of the containers that we are start seeing today and the microservices, but this is more targeting the data center. And of course, all of this concept is completely integrable via API. So I can integrate in any existing monitoring solution, which is usually, in what we saw, is a main concern of the enterprise. So how can I integrate this in my current mode of operation? Digging more on the network part. So as I was saying before, switching to the network part, we will see that the SDN solution usually will define a data plane, a control plane, and an application tier. What does that mean? So on the data plane, I will have my physical network device, but I will move the intelligence to not be done on this part, but I will do it more on the control and on the application tier. Mainly, what will that mean is that I will be performing only packet forwarding on the first, let's say, physical tier. And of course, this will mean that I can use different type of hardware which are usually cheaper. I can, of course, orchestrate and engineer better and standardize all the logical policing that I'm doing, and let's say the policy application will be based on the logical concept, not more on the physical. So as we can see here, what I did is that I put a small comparison of what we do here as an operation in the pre-SDN and in the new way. So after, let's say, using the SDN. So we can see that we are not defining anyway VLANs. We have virtual networks which are providing, let's say, a different concept of segregation between the elements which are the application that we use on the application tier. So I will be mainly seeing this as a logical big picture. So application A should talk to application B. I can chain them automatically. Chain them mean that I can define that this application is inside a zone, this one is inside another one, and I will put a firewall in the middle, and every time that I define a flow from application A to application B, this chaining will be implemented automatically. Of course, this will give a huge benefits in terms of cost reduction, and this is because actually the hardware will be, how to say, less in terms of quantity, but it will also be cheaper because I'm moving, let's say, to the upper part, to the logical part, all the brain, let's say. So I can use hardware which is less performant and also cheaper in my leaves, let's say, in a way that I can spare my compute and my compute capacity actually to my spine. For capabilities and clarity, it's pretty easy. So as I was saying, we will change the provisioning from weeks to minutes because the more I standardize and the more I will be able to generate automatically or manually, but let's say in a template-based way. So all the provisioning will be done really in minutes instead of hours. Clarity. So I have transparency because I have a complete picture saying which application is speaking with which one, and which I know exactly which application is the responsibility of which department. And this is also something that is important because this, let's say, the software-defined concept will also create a collaborative environment where, let's say, all teams can work. And there's no that much separation between the network team developing the network part and the application. Compliance, as I was saying, so standardization will give compliance because there will be no space for exceptions. So for this application, I will not define this. I mean, the policies are this one, and that's it. So seeing this in details, just a quick comparison with what was the legacy data center, so the 3 tiers that we used to have until some years ago, we can see that we had a lot of northeast traffic, so vertical structure of the data center. The growth was vertical, so if I needed to add more switches on the picture on the right, I was adding them in stack. I had blocking paths that were blocked, so from spanning tree and loop prevention. And of course, we can see that with the software-defined network, we will have a spine and leaf with a non-blocking equal cost multipath, which means actually that it's also for failover, but the more important is for higher performance, that I can have multiple paths reaching till the same leaf. Another thing that is key, we can see that the firewall on the right side are on the upper part, and there are usually they are physical or they are virtual, but on exact point that so either on DMZ or on critical points. In the software defined, you can see that usually we will put on each leaf a firewall, and this will give us, let's say, an orientation toward the microservices that we can define in our data center. We already spoke about this, but we will have change control, central configuration, automated documentation and audit, and the provisioning time will be switched from days to hours, as we were saying before. Switching to SD-WAN, which is mainly the evolution of the SDN, so the implementation of the same concept of SDN, but extended to the WAN. So how will that work? Usually what it will give me, it's a complete abstraction from what is the physical layer that I have. So usually what will happen today is that I will define MPLS link or any type of VPN over a public link or over a mobile link, and I will have, let's say, my branch and my data center which are connected over this link. If I lose this link, I have to have another one in failover, and I have to configure them. What will happen with SD-WAN is that I will have natively an overlay network, which is completely a logical network that is defined usually based on VPN mainly, but it's completely abstracted from my physical layer, meaning that I can have 1, 2, 3, 4, 5, or any number of physical layer, and they can be completely different. So in one of the last projects that I've been following, we had a couple of links of MPLS, and we started changing them because this is also one driver for which enterprises and clients are looking to change this to this solution. Beside the performance, also, of course, it's a matter of costs and to regain control of the, let's say, the connectivity. So in this project, we were actually moving from MPLS to internet. So, and it was like really moving, let's say, taking off one cable and putting let's say, the new cable of the internet link, but we didn't have to configure anything. And this is actually key for this solution because it's completely abstract from the physical part. It's completely secure because, as I was saying, it's based on gray tunnel and IPsec, depending on the solution. I will have central policies, central provisioning, central orchestrator. Usually what I will have is that I will have an orchestrator that is completely controlling and orchestrating all the branches, and this will be my point of auditing where I can see everything. It is oriented to the multi-cloud, so usually what will happen is that I will put my orchestration part either in some sort of carrier neutral place. So for instance, Equinix is a major provider. They will offer interconnection with different cloud provider. Of course, clients can build their own, but usually they will rely, let's say, on external carrier neutrality. Why putting my control there? Obviously, because I will let's say, move my point of failure the most near to the cloud. And so I can, let's say, ensure redundancy, failover, and performance to arrive there. And from there and on to the cloud, I will have my carrier neutral facility, so my IBX provider or whatever, ensuring the same and very low latency to the cloud. Security, as I was saying, it's completely secure thanks to the encryption. All the communication are encrypted. We have DDoS protection. It is compliant with GDPR, and we have unified threat because usually, I mean, all the solution have that each edge that we put in a branch will have UTM mainly, so unified threat management, and some of them include also L7 firewall functionality as, let's say, an add-on on the license. So this is mainly a framework that we defined, let's say, to put a little bit all the pieces together. So the type of sites will be access, which is mainly the branches. WAN aggregations, which will be some sort of super branch, let's say. So it's an aggregation for a branch. If I have 1,000 branch in a country, I will put one site of one aggregation where I can collect my traffic, but overall I can collect analytics and so on. And I can differentiate also the routing from if to pass from there or not based on application. We will see this in the next slide. CNC or colo, CNC is carrier neutral center or facility, as I was saying before, or colo will be handling the interconnection with the cloud. And of course, I can have also my cloud data center directly on the stack. I put also the SDI, SDC, and SDN on the lower part because this will be interconnecting my, let's say, the enterprise infrastructure. With the SD-WAN, I will be able to let's say, boost every connection that is going out. And I will be able to do a virtual service catalog that include actually virtual machine, virtual storage, until the network service chaining, as we were speaking before. So speaking about the main feature usually, so the overlay control plane is the one that I was speaking before. It's, as you can see in the picture, usually I will have a V-edge or two V-edges in a branch, and I will have a V-edge acting as a hub in my, let's say, hub and spoke. I mean, usually it will be a hub and spoke architecture, except of course, let's say, different scenarios. But usually large enterprises will have hub and spoke scenarios for all application with exceptions. So for instance, for voice over IP, I will have full mesh, not hub and spoke architecture. The link utilization is of course active. So if I have two V-edges with two links or one V-edge with two links, both links are actives. I am able to do what we call application aware routing, which is pretty explained very well here actually. So based on the color or on the application, I can define SLAs. So mainly, as the word says, it's a rule saying that for this application, you have to be compliant with several parameters. If you are not compliant, search for the link that is compliant with that. Usually the rules are based on 3 parameters. SD-WAN will use packet loss, latency, and jitter. So usually I will be able to define SLA based on these 3. Based on that, automatically the link will be switched from one link to another. Of course, I can also define a bundling of the links. So I can say, for application A that is very important for me, I would like to have all my bandwidth and prioritize it. It's some sort of QoS mainly applied to the connectivity. So I can use the totality of my bandwidth. So if I have 10 meg, 10 meg, 10 meg, I will use 30 meg for one application and put it as high priority, queuing everything else. So I have total control and total freedom in defining any rule I would like to use on my infrastructure, on my connectivity. Sorry. Of course, I will have complete alarming also on my links. So solution is natively collecting information about packet loss, jitter, and latency. So I will have, let's say, natively alarms on which are the links that are not working. So in my last project, as I was saying before, the one where we put the SD-WAN, we implemented directly over ServiceNow, integrating it with the SD-WAN solution, automatic ticket escalation to the providers. So when we saw that one link was not was not working, we escalated automatically the ticket to the provider. Of course, there were no outage because we had the path change automatic. And this is actually was also what is the intelligent path control. So we have the monitoring end-to-end. We have the possibility also to integrate POPs and to do also local internet breakout, which means that all the traffic will not have to be back to the data center to have the central exit, let's say. But I can exit from my branch over my internet link or over, let's say, a private link, so a VPN, to a web gateway. So usually it will be Cisco Umbrella, Zscaler, and so on. So mainly it's a proxy that will allow me to apply a set of policies based on the type of user. And this will be applied mainly all across the organization. So it will give me also a boost for standardization of all the policies across. So benefits mainly are one, agnostic, as we were saying, so it's completely isolated from any type of connectivity. I can change the connectivity, I can leave the connectivity as it is, I can have LTE, 4G, 5G, any connectivity, and I don't have to change anything. The important is I have layer 3 reachability between my controller and my branch. Improved availability, that's pretty, we already discussed this, but mainly I can have more links and more virtual CPE working at the same time, so I will have all my links up and balancing the traffic. Management, I have only one point of management, so I will have all my solution controlled, and usually it will happen from a portal. I will have one point, let's say, of access for the solution also toward an external monitoring solution or analytics, how to say, engine, which actually will give me also a boost looking at the future. So when we will start using artificial intelligence operation and so on, I will have only one point where to look at. Application-centric, this is actually all the software defined is about this. So we are switching from being, how to say, IP address centric or physical device centric to being application and user centric. So my element will be the application and the user experience. In fact, a lot of SD-WAN solutions speak also about QoE, which is quality of experience, applying, let's say, this concept of the user centric. Security, so as we were saying before, I have the possibility to isolate any segment of my network in case of attack. It is already segmented. I have complete encryption on all the solution. I have the service chaining that is as well, how to say, built in the solution. If I put a firewall and I can define which type of site will have the same chaining and the same architecture, and I will have it on all. Cost reduction, as I was saying. So usually the equipment will be a lot cheaper, either in OPEX and in CAPEX. So usually I will be able to save money based on the cost of equipment, but also looking at the operation cost and the connectivity cost, switching to the public connectivity. Just a quick approach on how usually we applied the transformation. Usually starting from a legacy MPLS, what will happen is that you can, enterprise can choose to go with hybrid SD-WAN, meaning MPLS plus internet, or let's say the more aggressive way that of course achieve more, let's say, benefit in terms of cost saving is the internet SD-WAN. So I will be changing both MPLS links that I have to more, let's say, higher bandwidth internet links. As I can control all my links, it is not mandatory actually to have business internet links. Usually what we've done is that we used consumer internet. So instead of 3 meg, we can get 100 meg, and we are still saving a lot of money. And of course, we can monitor the links and understand if there are problems and change them in case. A little bit about our point of view. So we accompanied actually our client, as you can see in the journey, starting from what is the high-level design and the service architecture. So the first phase will be to do with our client a discussion and propose to them a solution, an architecture, and define together what will be, let's say, their to-be architecture. Based on that, usually we go to planning and analysis. Usually what will happen here is that we scout the solution over the market. We can also do proof of concept. We can do live proof of concept, also using real traffic to convince, let's say, our client that this is the right solution for them. We will do planning. We will do analysis. We will do the validation of these tests. Of course, we will start after that doing the onboarding part. We will accompany also the operation, so the handover part to the operation team, and the decommissioning, let's say, so migration and decommissioning of what was legacy. We define our capabilities as four. So we have our technical point of view that we developed with, let's say, by studying and deploying the leading solution market. We have our deploy experience, so we learned a lot of lessons on our own skin. So by deploying several projects with several solutions. The lab, we have an internal lab where we have a preset of use cases, and we have our testing methodologies that we applied. Okay, so from our POV, so we defined a framework. We have a partner ecosystem. I reported here, which are, let's say, as per Gartner Magic Quadrant, the leader on the market, and actually we work with all of them. Mainly the higher three are the one where we had our major implementation. These are our major implementation. The first two are really huge. The first one is about 1,200, so 1,200 branches spread across all over the world. The vendor said that this is the bigger implementation that I've ever done. Second one is around 800, with the difference that it has different, let's say, several number of hubs. The reason where that actually, even though the number of sites were less of the first one, but they were spread across the globe. So we had to define IBX and cloud interconnection also in Singapore, also in North America, and so on. So let's say it's a completely different solution and architecture. The one that we have below are have the particularity. So the third one have the particularity that it is relying completely on the cloud proxy, so on Zscaler in this case. So they have the internet local breakout, as I was explaining before. And the last one, they automated completely the provisioning of new site, relying on their current infrastructure. And this is, as some of you can imagine, is relying on Cisco routers. As I was saying, we have an internal lab. It's called Accenture Cloud Innovation Center in Rome. It is a case-driven prototyping center. Usually what will happen is that we will meet the client, we will define a use case, and we will deploy it. We have already a series of use cases that we already deployed. So we have the segmentation. We have mainly the segmentation will be that I cannot access a server that is not in a segment of the network that I can access. Routing legacy sites, so how I will interconnect my overlay, so my logical network with my legacy sites that are not migrated to SD-WAN. Web internet security, as I was saying, so it's based on Zscaler. Active, I will remove one link and check if everything is still working. Video stream, this one is very interesting. Actually, what we will do is that we will stream a video, we will remove one link, and we will see that the user experience will not change. So this is meaning that the steering between the links is completely seamless to the user experience, let's say to the end user. MPLS and internet capacity bonding, as I was saying before, so we have 10 meg and 10 meg. We will be able to assign all the 20 meg to one application, and the transfer with link degradation. So mainly we will see that similar to the video, but with the transfer, that client is not impacted if I have an issue. Last thing is about our methodology. So in several projects, what we've done is that we started with the client from selecting the right solution for them. So we were scouting the market, defining, let's say, which is the right solution. I know it's pretty small, but I try to represent all the methodology. So we had this approach, let's say, scouting the solution, defining a testing scope. So which are the requirements of the client? Based on that, we defined a series of tests, and these were giving a scoring. Of course, we used a lab that was a multi-country lab internal to the client infrastructure. Of course, we can do it also on our infrastructure, but in this case, it was internal. And based on the result of these tests, we defined the scoring, which actually here was a little bit messy because it's not readable, but I can assure you that it had also a result. And score report was giving a score per vendor based on the category that we defined. We defined also spider charts and so on until we reached, let's say, to the final solution that we wanted to achieve and to select. I'm done. Thank you.